Alright, here is a just super simple one-dimensional momentum problem to get started with momentum. I've got two masses, m1 and m2. M2 is just sitting there initially, right, stationary, and m1 is coming in with this initial velocity that we know. So we know m1, m2, and we know the initial velocity. Then they collide right in the middle, or I guess it'd be right over here. They collide and they both bounce away from each other. So here's my picture, not to scale. Afterwards, we measure the speed that m1 moves away with. So we know v1, okay? Shall we make up some numbers here just so we remember what we know? So we'll say m1 is 1 kilogram, m2 is 2 kilograms, that's creative. We'll have m1 initial be 10 meters per second, and we'll have m1 final be, what? I don't know. It'll be 8 meters per second, like that. All right, and we are wondering, what is this v2 final right here? We want to know the speed that m2 moves off with after being hit. Okay, so this is a collision, right? And we know that momentum is always conserved in a collision. So I'm going to write out my conservation of momentum. Momentum final equals momentum initial. Now, it's a vector, but this is just a one-dimensional problem, so my one dimension is just, I could call it the x direction, but I have no point. I'll just say that this is the positive direction of my one dimension. And so in that dimension, momentum is conserved. So momentum final equals momentum initial. So we just have to write out the final and initial. So initially, we had the momentum of mass 1 plus the momentum of mass 2, initial, and at the end, we have the momentum of mass 1 final plus the momentum of mass 2 final. Okay, so that's pretty straightforward, but at some point, I need to take into account the direction of the velocity and therefore momentum. So I said that the positive direction is to the right. So that means, let's see, this v1 final, that is moving to the left. So the velocity in the final velocity for mass 1 is negative, or in other words, its momentum needs to go into my equation with a negative sign. Okay, so we are summing up all the momentums, just like we would sometimes sum the forces, but sometimes they have to go in as positive and sometimes they have to go in as negative, depending on their direction. All right. So there's my conservation of momentum continued. Now I need to plug in, well, I need to plug in the momentums using the definition of momentum. Momentum is mass times velocity. So this will be negative m1 v1 plus m2 m1 v1 initial plus m2 v2 initial. But wait a minute, v2 initial, that was 0. So mass 2 had no momentum initially, which we probably could have realized up here in this step, but whatever. So because it has 0 velocity, it has 0 momentum. So what we want to know is the final velocity of mass 2. That's right here, v2. We know m1, we know v1, we know m2, we know v1 initial, so the only unknown in this equation is v2. So in a couple algebra steps, we'll get that v2 is equal to m1 v1 initial plus m1 v1 divided by m2. All right, and so that is just a simple little one-dimensional momentum problem. Ta-da! I'll let you plug numbers in if you want, but I don't want to.